14b, question number 1. Ex when a equal 1, x equal 1, e1. We know this is the famous value 271,828. So we don't need a calculator. That's why we refer this as EE. So x equal 4, e to the power 4. That is going to be 54,59815. When x equal minus 10, e to the power minus 10 is going to be 0.05, and x equal 0.2, so e to the power 0.2, 1.2, 140. So you can find this one from your calculator. Usually shift, press then ln, and then type the number you want. Shift ln. Question number 2. Draw an accurate graph of y equal ex. So I'm not going to draw accurate graph, so you can do it. So this is the graph. So this is y equal e to the power x. So this is 0, 1. So you can draw the accurate graph taking some point x equal minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. Then you can find y values and then you can plot. So x equal, this is e minus 4, e minus 3, e minus 2, e minus 1, e0 is 1, e1 is 1, e2. You know that this y e to the power x mean y 2.71828 to the power x. So this is in the exponential form, 3x, this kind of graph, right? What will happen when you start using e, we will forget that this is a constant. Now we draw minus 4 to plus 4, and then part B, drawing apart tangent lines, estimate the gradient when x equal 1. Assume now in your graph where this is x equal 1, then this is the point for x equal 1 in graph. Then you want to draw a tangent line. And then find the gradient. How do you find the gradient? When you draw a tangent line properly, you can take a ruler, then you can measure this distance A and this distance B, and when you divide A and B, so you will get 2.71828. And then again it's the same thing you want to do for x equal 3. 1, 2, 2, 3. So draw a line. So when you done that one, this is x equal 3. Then draw a line to x equal 3 and find the gradient. This is P and this is Q. When you divide P, divide Q. So you will get 0.8553. This is when x equal 1. This is when x equal 3. Now, what we did, we draw a y equal ex graph accurately, and geometrically, we found out when x equal 1, we divide this distance and we get the answer. And we draw a tangent to this point when x equal 3, and p divided by q. We geometrically found the gradient at those point for y equal ex graph. Y equal ex graph. Now, how do you find algebraically this one? So y equal ex. What is the differentiation of y equal ex? Dy also ex. Both are same. Then at x equal 1, dy over dx when x equal 1, e to the power 1. What is the e to the power 1 from the calculator? 2.71828. At x equal 3, dy over dx equal x equal 3. That is E3. What is E3 value? 20.08553. Here we found out geometrically. We draw the curve and then we found out by drawing a tangent, and then we found out when x equal 1 the gradient of this place, and we found out geometrically now. Sorry, algebraically. Now x equal 3, we found out the gradient geometrically, and now we found out here algebraically. Question number 3, A. In this question there's a bit of issue because on the book I can see that this is ex plus 1, but the answer is different. They draw the graph for ex plus 1. So this is two different graphs. I'll show you for this one first. So this is y equal ex times e1. That's why ex plus 1. So it means y e times ex. Okay, I will replace this e value 2.71828. I will leave this is as ex. Then this graph is kind of when x equals 0, e0 is 1. So this graph is something like going 0, 2.71828. But the graph they want is this one. So we'll sketch this one. First of all, y equal ex. This is y equal ex graph. This is 0 and 1. Now I want to and this is the horizontal asymptotic, this line. This is also horizontal asymptotic overlap with x-axis. Now I want to shift this graph, ex graph, by up, 1 unit up. It means this 1 become 2 and this asymptote, horizontal asymptote become x equal 1. So basically we can see this is x equal x-axis, and that is y equal 1, and this is the curve. So this is going to be 0, 2. You can make sure that check in when x equals 0, e0 is 1 and 1 plus 1 is 2. Yeah, that's fine. So this is a translation of 1 unit up. translation of one unit up of this EX graph. And part B, y equal 4e minus 2x. So before draw this one, we'll just look at the shape of the graph to get an idea, sense about the graph. I know EX, then I know E2x, then I know E minus 2x, then I know 4e minus 2x. I know EX like this. E2x much steeper. E minus 2x opposite side the same size. Then it is going to be 4 times. Then it is much steeper. And when x equals 0, this is E0 is 1. So this is going to be 0, 4. I use my EX knowledge to adapt for this sum. So EX, E2x, my E minus 2x, 4E minus 2x. So the graph is going to be like this. 0, 4. When x equals 0, y equal 4e minus 2 times 0, 4e 0, 4e 0 is 1, 4. And now we want to discuss what will happen when x goes to infinity and negative infinity, because approaching to the next section. First of all, I would like to discuss here if you consider y equal ex graph, when x goes to infinity, what will happen to y? Y also goes to infinity. Can you see this graph? X goes to infinity, positive infinity. When x value is goes to here, y also goes to positive infinity. It means the only possibility is going this direction. Now, when x goes to negative infinity, this direction, what will happen to the y value? When x goes to negative infinity, y goes to 0. Likewise, what will happen to this graph? When x goes to positive infinity, y goes to 0. And x goes to negative infinity. When x goes to this side, y goes to positive. As I is going to this direction, y goes to positive. Part C. This is the graph. We'll see in terms of Ex. So you know Ex graph. Then you know 2 times Ex. It is a vertical stretch. Now this is 0, 1. Then this is going to be 0 to when x equals 0. And then this graph you want to translate. It's a translation. Shift down by 3 units. So then it is here. You want to bring 1, 2, 3. So in that case, this 2 become minus 1. This is 0, minus 1. And this 0 line become minus 3. This is y equal minus 3. So I bring everything unit. This point 3 units down. 1, 1, 2, 3. So it is here. Right? So likewise. And this point 1, 2, 3. 3 unit down. So 0 minus 1. So this 2EX graph, you want to bring everything 1 unit down. So this is the graph. Y equal to EX minus 3. Now what you can tell about when x goes to positive infinity, so this is x value, x goes to positive infinity, y goes to positive, x goes to positive, y goes to positive, that's why it's going this direction. And x goes to negative, y goes to where? Y goes to minus 3. Here x goes to negative, y goes to 0 line. That is the asymptote. Now the asymptote is y equal minus 3. This goes to minus 3. If I draw in one graph actually to understand, this is y equal ex. This is y equal to ex 0, 2, and bring this one down 1, 2, 3. So these two should be parallel. So this is y equal to ex minus 3. So this is 0 minus 1. And this is y equal minus 3 line. RD y equal 4 minus e to the power x. I write this minus ex plus 4. This is more practical. We'll get the idea about this graph. This is y equal ex. This is 0, 1. This is y equal minus e minus x. So this is y equal ex. Y equal ex. Now this is minus ex. All the values are now negative. So we are talking about y values. What is here? Positive. Now all that value is negative. Now this is going to be a 0 minus 1. Basically this is a mirror reflection. When you keep a mirror, so it will come to other side. So this is the mirror reflection. Now you want to shift this curve by 4 up. 1, 2, 3, 4. Then from here it is going to 1. It is 0, 1, 2, 3. When you move 4 units, you can see 3 here. So in that case, graph is parallel to this one, and this point is 0, 3. And so we move this one minus 1 to 3. This will become 3. We become this 0 asymptotic, horizontal asymptotic to 4 units. Then 1, 2, 3, 4. Like this. So this is y equal 4. So this is the graph y equal minus ex plus 4. Now you can see when x goes to infinity, this direction, y goes to positive, negative infinity, because that's why graph goes this like this. So x goes to positive infinity, y goes to um, negative infinity. Then x goes to negative infinity, x goes to negative infinity, x going to this direction. Then what will happen to y? Y is going towards 4. Y is going towards 4. So x goes to negative infinity. You can see that y is, this distance is increasing. Distance increasing, but it is not go above 4. It will touch the 4 line at the infinity. That's why x goes to minus infinity. Y value is goes to 4. If I draw this one in one graph, this is y equal ex. Then the mirror reflection y equal minus ex, and I want to shift this one 0 minus 1. This is 0 1. This set is 4 units up. So it means every point I want to move 4 units up. So then when I move 4 units, 1 2 3, somewhere here. This point 1 2 3. This point 1 2, sorry, 4 unit 3 4. It's here. So this is, so likewise this is the graph. So y equal minus ex plus 4. Sorry, this is the wrong graph. Y equal minus ex, mirror reflection. Now you can see that this is y equal 4. X goes to positive infinity, y goes to negative infinity. That's why it is going here. If you see in this direction, what is the x value? X is positive and y is negative. So x goes to positive infinity, uh, y goes to negative. If it is here, x goes to positive, y also goes to positive. If it is here, x goes to negative, this direction, y goes to positive. And if it is here, x goes to negative, then y also goes to negative. So this is positive, positive. This is negative, positive. This is negative, negative. This is negative, positive. Question number E. Now, when you look at this one, I'll see this is half. Whereas the exponential part, this is not exponential. This is not. This is the exponential part. Now, E, I can write half a times x. This E half is in between 0 and 1. In between 0 and 1. So then the graph is going to be like this. If it is greater than 1, A value, the graph is going to be like this. So when you look at this one, you want to get an idea by looking at it, what direction. So I will write this one, 6 plus 10 e to the power half of x. Also, this is not half a x graph. which is 2 to the power minus x. This is e to the power half x. So this is a different sum here, different scenario. Okay, we'll start with y equal ex. So this is y equal ex, and this is going to be 0, 1. Then e half x, it is going to be much less gradient. This is steep, this is less. So y equal half x, and this is also when x equals 0. X equals 0, y equal e half times 0, e 0. This is also going to 0, 1. Now the next one, 10 e half x. Y equal 10 e half x. It means we can clearly say this is 0, 10 now, because this is when x equals 0, this is 1. Now multiply by 1, multiply by 10, it is 10. Then this is plus 6. I write to like this graph like this, not 10 e half 6 plus 6. We want to push 6 up, whole system. Then this 10 become 16. This is 0 become 6. The graph going through 0, this is 16. Y equal 10 e half x plus 6, because this graph we shift by 6 up. It's a translation. Every point I need to shift by 6. So this point is 10, 10 more 6. This point is here, so I want to make 6 units. So it is here. And this is the horizontal asymptote. So where this horizontal asymptote like y x-axis. So then that one I want to more 6 units. So this is y equal 6 line. Actually we have to put a dotted line for asymptote, not a proper line. Now by looking at, you can see that when x goes to positive infinity, y goes this direction, mean y goes to positive, and x goes to here negative infinity, y is come and touch which axis, 6. So when x goes to negative this direction, so this y is come and touch 6 at the infinity, y equals 6. F, so first of all we want to look at ex, then e minus x, then 100 e minus x, then 100 e minus x plus 10. So first of all ex, so this is ex graph, y equal, then y equal e minus x, other way around. Then I want to, this is 100 times, so this is 0, 1, this is also 0, 1, so this is a shift vertical, so this is going to be 0, 100. When x equals 0, e 0, this is going to be 100. the same graph. And now I want to shift this one by 10 up. Then this is going to be, so this asymptote, horizontal asymptotic, which is x-axis, become y equal 10, because 10 up I need to bring into this graph. And then 100 become 110. So this is 0, 110. X and y. So now we can see that when x goes to positive direction, y is what is happening. This graph come and don't come up to x. It is end up with y equal 10. Y equal 10. X goes to negative infinity. Then x value when you put to negative infinity, y also getting y is getting positive. Negative, positive, graph goes this direction. X goes negative infinity, y goes to positive infinity. And let's look at question number 4a. So this is y equal a to the power a bx plus c. Now when you look at this kind of graph, so it has certain tasks in here. First of all, where is the exponential? This is not exponential. This is not exponential. So this is the exponential part. I always tell exponential not because of a. Um, it's follow the definition of exponential. This e value is positive. That's why it is exponential, positive constant. Now, when I consider this exponential part, if this value is positive, what is the direction? Be greater than 0, positive. The direction is this one. If be less than 0, the other way around. Be less than 0, other way around. So this is a one task of a B. Other task of B in here is stretching the graph horizontally. Right. Now we have A. What is A task? So this is B task. One is to decide the directions, other in is stretching around horizontal axis. Then what is the task of A? The task of A is stretching again along, stretching vertically. So this is for horizontally, this is vertically. Then what is the C direction? Translation. Oh, it's moving up and down. Up or down. If C is plus 4, C is plus C is 4, it's going to 4 up. C is minus 2, then it is coming down 2. So it is a translation. This person's task is moving up and down. This person's task is stretching vertically. This person's task is explaining the direction, the shape of the graph, and also with the shape of the graph with the positive and negative values, and the size magnitude will decide the stretching along x-axis. So that's how it is always. So you have to look at in that manner. Now, in this graph, when I look at, I can see that usually exponential graph, this is how you want to track that this part moving up and down. Usually, the asymptote is totic is y equal x graph is y equal 0 line, which is x-axis. But now in this graph, asymptotic is y equal 5. It means this graph move shift up by 5. It means C value has to be 5. Now C done. So we'll bring this graph down now. So when it's come down, 5 unit down, so 6 minus 5. So 5 minus 5 mean it will come to here. So this is become 0 and 1. So I bring that 5 down and see what is it without moving. What is the location when I get rid of this translation? It means this 5 I have to bring down. So 6 become 1 and 5 becomes 0. Now this is y equals 0 line. Now this is 0, 1 point. Now this graph is A, E, B, X. Now B is positive, so we know that this in this direction. Now at X equals 0, what has to be the y value? 1. So when X equals 0, y is 1. So will because 0, 1 point on this curve now, y equal AEBX. So then since 0, 1 on y equal AEBX, I took that C out, 5 out, and now this is going to be 1 equal A times EB times 0, which is A equal 1. So then we found out, so this is y equal EBX plus 5, A equal 1. Now this graph y equal A EBX plus C. Now when you look at this one, you know that it is shift up. So this is going to be 5. So you can work like that as well. And now this is going to 0, 6. So we'll substitute here now. When x equals 0, y is 6 for this graph. Then this is y equals 6. This is a times EB0 plus 5. Then again 6 equal a plus EB equal is 1 and 5. So a equal 1. So you can work like that as well. When you look at this one, you realize C has to be plus 5. Then you know that this curve is going through 0, 6 point. So substitute that values. So you can work like that as well. Now part B. So this is the curve. When you look at this one, you can see that the asymptote is still the same. It means there is no shifting up and down, no translation. Then C has to be 0. Now the graph is y equal AEBX. Now since 0, 4 point on y equal AEBX, so we'll substitute y equal 4, A times E, B times, this is 0. So 4 equal a times this value is 1. B times 0 is 0 is 1. A equal 4. And since the curved side is decreasing function, so b is negative, b less than 0. Part C. When you look at this sum, I can see this is y equal to, this is 2. It means this is y equal to line. It means the graph will shift up by 2. Then C is now 2. C equal to. Now this graph is going to 0.8. Since graph is going through 0.8 point, so what y equal AEBX plus 2. Now y value is 8. Since graph is going through 0.8 point, it should be satisfied. The point should be satisfied. Graph should be satisfied this point. So this is 8 equal a times e b0 plus 2. So 8 equal a b0 mean 1 plus 2. So 6 equal a equals 6. So then y equals 6, a bx plus 2. And it asking about b greater than 0 because it has a increasing function. As function is increasing. Question number 5. So this one we want to bring into this level. So when you look at this one, there is no translation. C is 0. So that is the information. So we'll simplify fx equal e 3x times e square. So then this is going to be e square times e 3x. So this value is e bx. So a equal e square and b equal 3. So when you draw this one, ex, then e3x, you want to get an idea, then ex stretching around horizontal, and this is positive side. So b value has two tasks. One is the direction, and so direction is and this is vertical stretch, e square e3x. Y equal ex. So y equal ex. This is y equal e3x, and then this is this graph. Y equal e square e3x. This is 0 1, so that one times e square, so this is 0 e square. So y equal 6, question number e6x. Now differentiate dy over dx is 6e6x. we have to write the same as 6x, then the differentiation of 6x. Right? Sometimes some student may write like this. This is right. Y equal E6x. Then we'll bring the operator d over dxy, and we'll introduce the same operator to this side because this is the equation. Then this is become dy over dx, and this is E6x differentiation E6x, then d over dx 6x. So this is E6x times 6. So 6 is 6x. So this is good in general, but if you plan to do maths in university, so this is the way you want to adapt. The other one is y equal e to the power 1/3 x. Then dy over dx is minus 1/3 this value times e minus 1/3 x. So minus 1/3 e over minus 1/3 x. So y equal e minus 1/3 x. So I'll bring the operator d over dx operator to both sides, and I put y here and e minus 1/3 x. Basically I put d over dx to both sides. So this is become dy over dx, and when you differentiate this one, the answer is e minus 1 over third x, then d over dx, this bit, minus 1 over third x. So which is e minus 1 over third x times minus 1 over third. So minus 1 over third e 1/3 x. If you can understand, that's fine. For in here, if when you e to the power minus 3x, when you differentiate, you will get this one, and then d over dx minus 1 over third x. So basically in here we write all two together, so we don't know what is going on here, but we assume we practice a method and we apply simply. The other sum, part C, then dy over dx is 7 times 2 e2x, which is 14 e2x. Now y equal 7 e2x. So introduce the operator d over dx. So dy over dx, then constant you can't do anything, you have to take constant out, e2x, then 7 e2x differentiation is e2x, then d over dx 2x. So 7 e2x d over dx 2x is 2. So then 7 times 2 14 e2x. So this is the really what is happening, but we write answer like this by looking at this one. When you see, okay, 7 we don't do anything, so we bring 2 here and e2x. So by looking at the situation, we adjust in this one. But this is what is really going on. So don't worry about this one. So it's better to know that this way, but just forget about this one. The important thing is passing the exam. So if you can understand this one, you can do this. But definitely you may learn if you do the maths in university. If you are not used to do this way, you are in trouble. Not in trouble, I mean it's a bit kind of a tricky to get into the track. Everything is possible. Now I'll show you a simple example. Instead of x, I put sin x here. Now what will happen? Now you can't do anything here. So because then only this one works, because since you know the rules, you can apply. But this is bit advanced, so y equals 7 e 2 sin x. So then we'll bring the operator d over dx, d over dx. Then 7 is a constant, I have to take it out. Now e2 sin x, so then 7, this is going to be same as e2 sin x, d over dx, 2 sin x. So 7 e2 sin x, d over dx, 2 sin x, you can't do 2. So then you have to take 2 out. So d over dx sin x. Then this is 7 times 14 over 2 sin x times this sin x differentiation cos x. So 14 2 sin x cos x. If you know this algorithm here, like the way it works, so then in any place we can simply by looking at, we can write. So for example, this one, we can write, okay, 7, then e2 sin x, then differentiation of this one, that is 2, and sin x cos x. So 14 e2 sin x cos x. So if you know the algorithm or the way it works, it's just a matter of seconds. So this is y equal 5 is 0.4x, then dy over dx equal 5, constant as it is, 0.2 times e 0.5 x. So this is going to be 2, 5 times 0.2 is 2 e 0.4 x. So this is y e3x, so this is going to be dy over dx is, we apply separately. So 3e3x plus 2 as it is, 1 e x, 2 times 1. So this is 3e3x plus 2 ex. Y equal e3x plus 2 ex. So bring the operator, is equal, then d over dx e3x plus d over dx 2ex. So this is e3x d over dx 3x plus 2 d over dx ex. So this is e3x times 3 plus 2ex. So this is y equal ex times ex plus ex. This is y equal e2x plus ex. Then dy over dx is, this is 2e2x plus ex. Question number 7, this is y equal 3x, then dy over dx equal 3e3x. Then dy over dx when x equal to the first one, that is going to be 3e3 times 2, 3e6. So dy over dx when x equals 0, then 3e3 times 0, which is 3 times 1 equals 3. And dy over dx when x equals minus 0.5, 3e3 minus half. So this is going to be, yes, 3e minus 3 over 2. Question number 8. There's a function this is fx equal e to the power 0.2x, and this is x equal 5, this is 5 e point, and at this point, or the curve, the tangent is going through origin. That's what we need to show, that one. We need to show. So first of all, we need to find the equation of the tangent. We have a point. This is like a like linear equation sum, and we did this kind of in dy by dx, the differentiation session chapter. So we'll find the gradient of this line. Let's say L1. So gradient of L1. So curve is fx equal a 0.2x, and then the gradient of the line is equal to the gradient of the point of this. So f dash x equals 0.2 a 0.2x. Then at point 5 the gradient. So when x equal 5, f dash 5 is 0.2 is 0.2 times 5, which is 0.2 e5 1, or this is 1 over 5. 2 over 10 mean 1 over 5 e. 0.2 mean 2 over 10, which is 1 over 5. Now I have the gradient of this line M. Now I have a point. This is 5 and E. So I can write the equation of this line now. Y minus y1 equal M times x minus x1. So y minus y1 means E equal M is 1 over 5 E times x minus 5. Y x value is 5. So we consider 5e point. So this is going to be 5 minus e. I'm not going to simplify because that is not necessary. So this is the equation of the line. I want to show that this line, this is the, actually we'll simplify sometime. We can get easily. That's what I see. Y equal minus x. So 1 over 5e times 5 times 1 over 5e. So this is this is become minus y minus e equal 1 over 5e. This is x times e. So minus e to minus cancel out. This is y equal 1 over 5ex. This is y equal mx form. Hence L1 is going through 0 point, because y equal mx type of graph is a linear line which is a line which go through 0 0. So that is y equal mx. The other way, initially I thought, because suddenly I see the calculation is giving easy, otherwise we want to show this is going through 0 0. Since if points going through 0 0, it should satisfy the equation. So we'll see whether it is satisfied. So LHS equal y minus e. So what is the y value? 0. 0 minus e is minus e. Now what is the RHS? RHS equal 1 over 5e x minus 5, which is 1 over 5 e 0 minus 5, which is 1 over 5 times e 1 over 5 times e times minus 5. So this is minus e. Hence LHS equal RHS. Hence L1 is going through 0 0 point.